Hi, my name is Daniele Miorandi. I am the head of a pervasive computing and communication area at CreateNet, a research center located in Trento, in northern Italy. But actually, I think it is more relevant here to mention that I am the coordinator of the Bionetics project. Bionetics is a rather large-scale collaborative project funded by the European Commission in 2005 with 17 partners, a budget of about 7 million euros, spanning 50 months of work, and you can really consider it as kind of the flagship European project for research on bio-inspired ICT systems. Now, concerning actually what I do in terms of research, beside of course the boring management activities you might imagine, I come as a background from the wireless networking field. But in the last few years, of course, as a consequence of this Bionetics project, I've been working quite a lot in more general distributed ICT systems, and in particular on the application of biologically inspired techniques for designing and managing them in an effective way. I think really the appealing fact about working on these bio-inspired issues is that it gives you just a different perspective on how things should be designed and engineered. There are various biological processes and phenomena that we used, or at least we took inspiration from in the last years and applied them to ICT systems. Just to mention a few of them, we've been working quite a lot, for example, on how to optimally design mechanism for diffusing data in pervasive computing environments. And it turns out that the optimal way of doing so is just to do it in an epidemic fashion, in much the same way a virus can spread among people and so on. We have been working quite a lot on attempts, partially successful, partially unsuccessful, to embed evolutionary processes in network protocols, so that protocols are able to adapt and develop new functionalities at runtime in a distributed and totally unsupervised way. We've been taking inspiration from cellular developmental processes for devising new techniques and methods for handling, configuration, deployment, and management of distributed services, plus a lot of other things of more, if you like, theoretical natures, related, for example, to the application of game theory as a tool for optimal design, or, for example, to the application of activator-inhibitor mechanism or similar reaction diffusion systems, to the design of, let me say, some emergent systems. I mean, ICT systems in which you see an emergent behavior but fulfills some given system level goals, and still this is done in a totally distributed and unsupervised way. It's not easy to tell it now how future pervasive computing or pervasive adaptive systems are going to look like. The way I tend to look at them, and this is actually just, let me say, an image I have in my mind, is that pervasive computing system, the computing systems we are going to have in 20 years from now, will be stochastic in nature. They will work in statistical terms. Just imagine a system in which you ask, how much is 1 plus 1? And if you're lucky, it tells you 2. But it might actually happen, but it tells you 3, it tells you -5, it tells you other things. So I think the big problem behind pervasive computing and pervasive adaptation, and where actually this biologically inspired stuff might play a fundamental role, is in changing the mindset of the system designers. Because you need to move from, let me say, a conventional engineering approach in which you basically design a system that has to be purposeful and correct by its own nature, to something that works on the basis of, let me say, kind of emergent behavior, in which on the average the system will perform what it was meant for, but you are not really granted that one single instantiation of a system will actually do what it is meant for. And actually this is, I believe, a big step forward that people have to take. And this is actually where I believe initiatives like Perada and all these projects, and in particular the Panorama Coordinated Action, should play a role in educating a new generation of scientists and researchers that can look at problems from a different perspective. Keeping in mind that if you want to solve all these issues related to scalability, to adaptability, to heterogeneity, to the complexity of the management task, we need to give up on something. And that something is actually the predictability in the system behavior. I think this is really the key point, and I'm sure you're going to do a great job in this respect.